Okay, yeah, we're live now.
Awesome.
So first two, got him.
All right. Find the margin of error for the 90% confidence interval when the standard deviation is 50 and the n is 25. So it was the 90%. So
you got to go put that into the probability applet.
no, because they gave you, well, if you wrote down the confidence interval, like the z-scores
so is that
don't
X then?
change.
Confidence interval? No, is that Z, right?
Z star? Is that what you're talking about?
No, because you do X bar plus Z and then standard deviation divided by square root of n.
No. You're talking about the upper and lower.
Oh yeah. I'm talking about something else.
The margin of error is the X star or whatever times divided by the square root of n. What's up, baby?
Hold on, I'm gonna get my calculator real quick.
Who is? Seriously, dude, I am in class. You are 7 years old. You can hug your sister better. Now go be nice. Why don't you guys turn on a movie and then I'll be out in just a minute, okay?
Can we have popcorn? I think we have it.
If we have any, I will make some. But I don't think we do. Out, out, out. Good help. Sorry.
Oh, dude.
All right, so
margin of error is 2 times, and then it's the
1.645
standard deviation.
Times standard deviation was 50 divided by I have like my crappy calculator. I can't find my good one, so this is gonna be difficult. What the crud? Oh my gosh.
50 divided by the square root of n is 10.
Yeah, and then times 2. But I don't think that that's how you do this, because that would not make sense.
No, the margin of error is just the z, like star.
What's the 90% confidence interval?
The 90% confidence interval is saying that we are 90% confident that the true mean is within the two numbers. But all they want you to know with the 90% confidence interval when you're working out the margin of error is that the z star, if it's 90%, is 1.645. Does that make sense?
Mm-hmm. Wait, where'd you get that number?
That's the number that they want you to like plug into the applet, but so you use only the 3 confidence intervals throughout the entire class. So you use 90%, 95, and 99, and they give you the Z star for each of those so that you don't have to plug them into the applet every time. If you write them down, you don't have to use the applet.
Z star.
Because they don't change.
So we're not multiplying 10 by 2, we're multiplying 10 by the confidence level. The Z star.
Mm-hmm. Yeah.
Okay, yeah, I see it.
Oh my gosh.
1.45. Okay, 16.45.
Okay, finally. Sorry. My stupid thing is being so stupid. So it's 1.645
times 10.
Oops.
16.45.
1.645 times 50 over the square root of
25.
25. All right, sorry. So I got 16.45.
I got 19.45. Wait, so did you just times 1.945 times 50 divided by root 25?
It's 1.645
Oh,
times 50 to divide by the square root of 25.
okay, then yeah, it's 16.
Oh, oh my gosh. If it asks us to round to the third decimal spot, do we do 16.450?
Yeah, that's what I would do.
Sorry. All right, which of the following statement is true?
Hmm.
Isn't it mu is the estimator of x bar? I have no idea.
You said the interval estimator?
It's the point estimator. I have that written down.
I actually don't know that one. The homework was kind of hard for me.
The point estimator equals x bar. Well, the point. So.
But
all I have written down is the point estimator equals x bar.
yeah,
That's
but
all I have written. So, but the mu of the mu is the sample mean. So wouldn't that be mu is the point estimator of x bar? I'm so confused.
I'm not sure. That makes sense to me, but I can't really say. Oh, yeah.
Because
The laws of probability and normal distribution provide a way for us to create a range of possible values for a parameter. Example, u, based on the statistic. Yeah, that is it.
Okay, so C,
Where
I
did you
guess.
find the answer in the reading?
It is in 3.1 point estimators.
3.1.
It's like right before 3.2.
Okay, so the very beginning. Okay, so what did we decide this is then? It's
C.
Yeah.
Okay. Use a point estimator of x bar.
Mm-hmm.
And it's not the other way around.
Yeah, I think so. Okay. Gina wants to construct a 95% confidence interval for her GMAT scores. She knows the standard deviation alpha equals 113. She collects a simple random sample size and n equals 64 and computes x bar to be 526. Use this information for the next 6 questions. So the point estimate for the GMAT score, I think that's just 526.
I think so too, but I'm confused. Let's just put it, and then if it's wrong, we can.
Yeah, because point estimate, yeah, we.
Do you agree with us?
Yeah, I agree with that.
Okay.
Because it's the mu of the mu or whatever. What is the margin of error for the 95% confidence interval for the true GMAT score? So the 95 confidence margin of error. So we would do it's 195, right? Or 95, right? So it'd be 1.96 times, what was it, 64?
Yeah.
Yeah,
Oh, wait.
113
No, it's
divided by square root
113.
of 64.
Yeah, 113.
I got 27.685.
Yep, 27.685.
Wait, how did you guys do that?
It's 1.96.
Oh, never mind.
times-
Never mind. I like plugged it wrong. I put 0.96.
Mm,
Okay. Sorry.
that'll get you.
I was like, I'm pretty sure I'm doing this right. This is confusing now.
It's so much easier if you just write down the confidence interval like Z stars, because then you don't have to look them up on the applet, and they never change, so it's just easier.
Okay, so now what we have to do for the next two questions is really easy. So we use this number, the 27.685, and then we take X bar plus this number and X bar minus this number.
Right. So for this one, it's going to be the minus one.
Right, yeah, the lower
5.6.
confidence interval. So
Minus 27. I got 498.315.
got that too.
Fine. All right. 498.315.
Yes.
498. No. All right.
And then the upper limit.
498.315.
Upper limit, I got 553.685.
That's what I got too.
What did you guys get?
For the
550.
upper limit,
Okay.
go ahead.
For the upper limit, I got 553.685.
Okay. All right. Sorry. I'm caught up now. If she increases the sample size,
It
then
would decrease the.
yeah, it will decrease the width.
Okay. What will happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
Then
Z,
it will
so the Z
increase.
star is going to be bigger.
Yeah, it will increase because it will increase if the confidence level increases.
Okay, Bright Bulb Light Company is planning to study to. I cannot read today. Sorry.
Right with ya.
Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulb. They know the standard deviation is 400 hours, and they want a 95% confidence interval with a margin of error to be 50 hours. What sample size do they need?
All right, so this one it's 95%.
Yeah.
So 8.96.
Sample size do they need?
Times.
So we just solved for N then, right?
Yeah. And they gave us the margin of error, right? Yeah, 50.
Wait, so Z is 1.99?
No, Z is 1.96.
96.
So I got 246.
I'm not there yet, sorry.
Yeah. So what did you set the equation equal to be able to bring the sample size over?
So the sample size, I did in parentheses, I did 1.96 times 400 over the top of 50, and then squared, or like with the little 2 on the outside.
Mm-hmm.
that makes sense.
Raised to the power 2. Yeah, squared.
Sorry.
What did you
So
say you got, Charity?
I got 246, rounding up.
Okay. Yeah, perfect. That's what I got too.
Explain to me one more time how you did that, how you did the math.
So the
So you
equation. Okay.
Sorry. So you
No,
take,
go ahead.
see if I can.
Oh, M equals Z star.
Z star times
Oh, okay.
the standard deviation divided by
Square
the
root of
margin
N.
of the margarine, the
Margarine.
margin of error.
So
and
you
then to
multiply
square
the
root.
N over and square root of N. Okay. Squared. So N times M.
What?
So the equation is N equals Z on top.
So it looks like this. That's the equation.
Okay. Okay.
Are you still confused?
No, yeah, I got it. So the standard deviation 400 times 1.96, is that it? 1.96.
Yeah.
Yeah, one.
0.96 equals whatever divided by margin of error of 50, and that's squared. 245, 862.
Yeah, but even if it's like 0.0001, they want you to round up because they want you to have the least amount of people it takes, and you can't have point something people.
Oh, if you get 101.2, round up to 102, so 246.
Yeah.
Okay, almost done. The mean salaries of actuaries is mu equals 100,000, and the standard deviation is 36,730. You are interested to know the mean salary for women actuaries is different from the population mean, but you are not sure if it is higher or lower. You set up a hypothesis test with a significance, with a level of significance alpha equals 0.05 and HA equals those numbers. You collect random samples of N equals 36 women's salaries to find out that X bar equals 111,000. Use information to answer the rest of the test quiz. The lower limit, what is the lower limit of this 95% confidence interval?
95%. Okay.
So the lower limit, we are looking for
36.
standard deviation.
To the top of. Oh, this is a weird one.
Yeah, you have to figure out a lot before you even do anything.
I got 122,998.4667. These
Yeah,
numbers
I
are
got
huge.
1199.8. Well, that's just my Z star times my other ones. I still need to subtract X bar. So 11, 1, 2, 3, 1, 2, 3.
No, we're doing the lower limit.
Lower
Sorry, I
limit,
did the
I've got
upper.
99,001.
Sorry, I did the upper limit. Hold on.
So it's going to be 99,002.
Round to the nearest whole number. Yeah. So 99,002.
And then the large is going to
These
be
numbers are
that number
big.
plus 111,000. The large is 122, 999, or is it gonna be 998? Just says
It's gonna be 998.
okay. What? How do we know when we have to like round up no matter what versus just following
It's just on N where you have to round up no matter what.
just on
because
M?
N
N. Okay.
on your sample size.
Right. Yeah, because you can't have 0.5 of a person. You have to round up in that case.
Yeah, but if you have anything lower than, even if it's like 0.01, if you have lower than 3.01 or whatever, you're not going to get the right answer.
Mm.
So you have to round up.
Okay.
So the upper limit was 122,998, right?
Yeah.
All right, the three requirements need to be checked when computing a confidence interval are, they're all of the above.
Yeah.
Okay.
A simple random sample was drawn from the population. X bar is normally distributed, and standard deviation is assumed to be known. Yeah.
Okay, I'm submitting it.
Okay. Are we still recording?
Um,